All right, having discussed the case of simple root and also complex root, now let's look at the repeated root, okay? So what's happened, how do you write the solution when you have repeated root from this polynomial? So basically, I'm giving you an example here. I want us to solve this example. Of course, question A here is very simple. So I just want us to use A to solve B, okay? So remember that as I say in the first videos of this series, that 1 and 2 are equivalent. So what does that mean? It means that here, this is similar to y prime plus 4y is equal 0. And this one is similar to y prime prime. This is the third derivative plus 12 second derivative plus 48 first derivative plus 64 y equal 0. All right, let's start with A. For A, we know that if you let this y equal lambda this, then this equation become lambda plus 4 is equal 0. This means lambda is equal minus 4. Then the solution in this case is simple. It's just y equal a times e to the power minus 4x with a in R. All right, if we know this, let's move to B and do it quickly. Let's use this form, okay? This will be lambda plus 4 to the power 3 is equal 0. What does it mean? This means that lambda is equal minus 4. Another lambda is minus 4. And another lambda is minus 4. This is called repeated root. So when we have then repeated root, how do we write the solution? So look at this. One solution is, let's call it y1, is e to the power minus 4x. The second solution here will be x times e to the power minus 4x. And the third solution here is x squared times e to the power minus 4x. Okay? So basically, here we have a polynomial of order 3. In here you have 3 minus 1. So it should be, the power of x should be n minus 1. Okay? Where you have to stop should be n minus 1, because you start here with x to the power 0, x to the power 1, and x to the power 2. All right, if you want to write down then the general solution, it's just a linear combination of this function. This is y equal a times e to the power minus 4x plus b times x times e to the power minus 4x plus c x squared times e to the power minus 4x. A, b, c, all are real. Okay? So this is the solution. Generally, in some textbook, you see that this solution is factorized. It can be something like this: a plus bx plus c x squared times e to the power minus 4x. So they are all equivalent, okay? So whether you have this form or this, they are all equivalent because they have factorized the exponential terms in the second form of a solution, okay? So in general, if we have an equation like this, d plus k to the power n times y is equal 0. The auxiliary polynomial will lead you to p of x is equal lambda plus k to the power n equal 0. All right, depending of the value of k, so if you solve here, we have lambda is equal minus k, okay? And to write down the general form of the solution to this equation, this is y is equal, whether we use this or this, it shouldn't be a problem. So I like this second form, okay? So let's take a1. I won't use a, b, c because there's a lot here. I'll prefer to use a1. a1 plus a2 times x plus dash 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 plus, as I say, this is x to the power 2 because here it was a polynomial of order 3. So it means that if you have a polynomial of order n, in this case, then you will stop at a to the power n, x to the power n minus 1, okay? All this multiply by e to the power minus kx. Of course, a1, a2, and so on up to an are all in R. All right, this is a general form. So every time when you have any form of repeated roots, just make sure that you follow this rule, okay? And you won't have any problem. Now let's look at this. What if you have repeated root with complex solutions? So let's take this example. Okay, let's take this example. In a previous video, we solved the case of this polynomial, but with the power 1 here, okay, of this polynomial. So it wasn't 2. And we find out lambda is 1 plus minus I root 2, okay? So in this case, we have this power 2, so it means this root is repeated. So this is lambda equal 1 plus minus I root 2. How do we deal with this solution? So the solution is simple. Remember, if we only have one solution, we have something like this: y equal a plus a times e to the power x cos square root of 2x plus b times e to the power x sine square root of 2x. But now that we have repeated, okay, so we have to add plus cx times e to the power x cos square root of 2x plus d times x e to the power x cosine square root of 2x. So in this case, we know also that a, b, c, and d are all elements of R, okay? So this is the general solution. So don't be afraid if you come across such example where you have repeated complex root. So you just have to follow the same pattern. Now what happens if, this is just an example, if I solve and I obtain something like this, the root is minus 1, 2i, let's say plus minus 2i. Can you pause this video for 2 minutes and just give me the general solution? So if you solve this, if you solve the auxiliary polynomial and you obtain this root, I want you to propose the solution. Pause this video and I will get back to you after 2 minutes and give me your solution. All right, I hope you get the solution. So my solution is the following. Y is equal, if we start with this first one, this is repeated real root. So this is a plus bx. So I just choose to write following this second form, okay? It doesn't matter, you can still expand it, times e to the power minus x, okay? Plus the second part here is c times cos 2x plus d sine 2x. And that's all. So with a, b, c, and d real. So this is the solution. So I hope you were able to get this solution. If you can't get this solution, you just have to check again, follow the procedure as I say. You know how to find the repeated simple root, and you also know how to find the complex root. So this is just a combination of these two, repeated and complex root, okay? This is all for this video. So in the following video, I'm going to give you more examples from the tutorial where you'll be practicing these 3 steps to build your capacity in solving linear homogeneous differential equation with constant coefficient. Okay, that's all. Thank you.